Hello, it's Miss Bryant again. I am not on the screen for this short little video because this is a rather big chart and I want to make sure you can see it all. So the last real important part of this unit is pH, because water can affect pH quite a bit, and pH is incredibly important to know in any item you encounter. And pH, as you probably remember, is how acidic or basic something is. And why it matters is quite simply safety. Is it safe to touch this item? Is it safe to consume? And the reason is cells and organisms need very particular pHs to survive. And your pH varies in your system. The pH of your saliva is different than the pH of your stomach. And if you were to take cells that normally live in your stomach and put them in your mouth, they're not going to live well. If you take the cells in your mouth and put them in your stomach, because of the pH difference, they're not going to survive. So we just need a brief overview on what it means for something to be acidic, basic, or neutral. So water can break apart. Covalent bonds are incredibly strong, but you can still break them. Depending on the broken pieces of water, and the amount of those broken pieces will determine whether an object is acidic, neutral, or basic. If a solution is acidic, it has a great deal of hydrogen ions, so H+. Now remember, ions with pluses are cations. That means they are lacking electrons. So if you break the water and you end up with a bunch of hydrogen ions, you have an acidic substance. That's something that's going to range between a 0 to 6 on a pH scale. If we go up the pH scale, the number of hydrogen drops. If we go down the pH scale, the number of hydrogen ions will increase. So anything acidic is from 0 to 6. 7 is our neutral. That means the amount of hydrogen and OH or hydroxide pieces are equal in the substance. So we have equal parts, so they kind of cancel each other out, so there's nothing really to worry about there. Water, in its purest form, is neutral. A base is anything at the upper end of the pH scale, anything from 8 to 14. This means there's a ton of water pieces that are OHs, or hydroxides. Now this is a ion that is an anion because there is a negative symbol. This means there are more electrons in this ion than protons. When you take a hydroxide in a solution and when we look at the amounts and we go up the pH scale, we increase the pH scale from say 2 to 4, we're going to see an increase. So the higher you go up the pH scale, the more hydroxide you're going to see and the less hydrogen. The more down in numbers of the pH scale you go, the higher the hydrogen and the lower hydroxide. To give you an example of some specific things on the pH scale, battery acid is about a 1. It's incredibly acidic. You would not want that on or in your system. Lemon juice is a 2. Vinegar is a 3. Milk is actually a little acidic. It's a little bit under 7. 7 is pure water. Blood is about a 7.35. Baking soda and seawater is about an 8.5. Milk of magnesia, which is used to settle stomachs, is almost an 11. It's around a 10.5. Ammonia, which you don't want on your skin or in your system, is a 12. And lye turns organic tissue into soap, especially fat. You definitely don't want that on or in your system. That sits at a nice 13. That's pretty potent. So the closer you are to the middle, the safer the substance is for your system in terms of acidity or alkalinity or basicness. The further away, the more dangerous it becomes. Excess quantities of vinegar or lemon juice in your system will really upset your stomach, as well as too much milk of magnesia or Tums, because Tums does the same thing. But just remember, this is more important for safety. You should be relatively knowledgeable in terms of pH in your everyday life. You should know what's safe to consume and touch and why. And that's because of these bits of water molecules that are broken up in solutions. Depending on how much more you have of a certain type, a piece of that water molecule will determine whether something's acidic or basic. And that's why we talk about this in the water chapter, because it's water's fault that something is an acid or a base. And that's a little bit about that. And that is it for the rest of the material you need to know for this chapter.